Welcome back for the last video for chapter 6.2. This little last 2 pages is all about assessing normality. So in chapter 6, we've been talking about the normal curve, and the normal curve is centered at 0, has a standard deviation of 1. And we need to look at this assessing normality because we're going to be looking at data sets in chapters 8, 9, and 10. And looking, sometimes we have to know that they're coming from a normal data set, and they haven't told us that already. And so we have to be able to decide that. We're not going to be actually creating our own normal probability plots, but we need to know how to read them. So it says, reading a normal probability plot. If a sample data are taken from a population that is normally distributed, the normal plot will be approximately linear. So this example here says a group of students collected data on the speed of vehicles traveling through a construction zone on a state highway, where the posted speed was 25 miles per hour. The recorded speed of 14 randomly selected vehicles is given below. And so we have 20 through these numbers here. These are 14 data points. And when we put them into a normal probability plot, we get this data here, and it does appear linear. Okay, so yes, it appears linear. So we can say the data is normally distributed. Now, example 2 is a different data set. And it says the National Center for Educational Statistics 2000 school survey on crime and safety gives data on several aspects of safety in public elementary and secondary schools. One indicator of safety in a school is the number of out-of-school suspensions in a given year. You'd like to have fewer in-school suspension or out-of-school suspensions as possible. Use a normal probability plot to assess whether the sample data could have come from a population that is normally distributed. So here's the various data. It's not in order of any particular value of smallest to largest or anything. But when you put the data in and run a normal probability plot, you get this. And this shows that the data is not normally distributed. It's not linear. And so we cannot say the data is normally distributed. And again, being able to look at these probability plots is going to be important in the later chapters of 8, 9, and 10. Catch me back for another lesson and moving on to chapter 7.